So in general, in the process of extraction with this magnesium, we use either seawater or the bittern solution. So what is bittern? So bittern is when you form the salt, sodium chloride, the remaining amount, the solution is normally called the bittern. So this bittern has like 13% of magnesium 2 plus. Okay, so you use this one. Then other than that, you can use limestone, calcium carbonate, or even dolomite, calcium carbonate dot magnesium carbonate. All those two can be used. So in the first step, you heat this dolomite or calcium carbonate to get calcium oxide and carbon dioxide. So here there is a disadvantage because you release greenhouse gas carbon dioxide. But what to do, we don't know. But this could be the use is we need calcium oxide. So since this reversible, you can also remove carbon dioxide efficiently to shift this equilibrium towards the right hand side. So this is also good. Then this is the first step. So you have the calcium oxide. Then what you do is you react this calcium oxide with the bittern solution or seawater. And in that process that you are going to get the calcium hydroxide sulfide, so precipitate. Okay, so here it will give the calcium hydroxide solid. So basically the reaction happens between calcium oxide plus water initially. Okay, so calcium hydroxide is formed, and this calcium hydroxide would give OH minus to the medium, right? Calcium 2 plus, because it is little bit solubilized. That is the reason, because when you have calcium 2 plus and magnesium 2 plus, so you are trying to precipitate magnesium hydroxide is not advantageous because there is calcium hydroxide, but still the solubility of calcium hydroxide is greater than magnesium hydroxide. Okay, so that is why we can use this one. So calcium is going to given out 2 plus and OH minus, and this OH minus will be taken by magnesium 2 plus in the solution and is going to precipitate out magnesium hydroxide. Okay, so that's the idea. And then when you have magnesium hydroxide, so then finally you add HCl to make the magnesium chloride liquid. So you evaporate water then. So you will have the solid MgCl2 like 2H2O solid. So here it will be MgCl2 like 4H2O liquid. So you evaporate it, so it will be MgCl2 2H2O solid. That means you cannot completely remove, but still you can remove, right? That's the idea. Then what you can do is you fuse these things and you then do the electrolysis. Okay. When you do the electrolysis in cathodes, you can have magnesium 2 plus 2 electron, will give magnesium liquid. So we obtain in the molten state because and the density is also very low than the magnesium chloride solution, so it will be on the top. And in the reduction, sorry, in the oxidation, Cl minus will be oxidized to Cl2 gas. That's the other thing. Okay, this is what normally happens. So here we have given a flow chart. It should be very similar to this one. So we will see. The flow chart given above indicates the production of magnesium using the Dow process. Okay, so this is the Dow process, entire process. Identify the starting material A. So you see here the starting materials that we normally use here. For this one, seawater or bittern or limestone or dolomite. So from here, B, you see here we have obtained calcium oxide. So this calcium oxide should come from calcium carbonate through a B process, because they are asking here, identify the starting material. So we don't know what is this starting material coming from. This calcium oxide, it can be either from limestone or dolomite. Okay, so this starting material A should be then surely either seawater or bittern. So this should be either seawater or could be a bittern solution. Okay, don't forget. Identify the processes employed at BCDE if and okay. So from the list given below. So they are telling identify what are these processes. So don't get confused. Here the boxes are processes, not the products. The products are given in these circles. Normally in previous question, this was the other case. They will give the processes in between the arrows by using circles and the products in the boxes. But now this is the other way around. For an example, now you have this calcium carbonate. To get calcium oxide, the product is calcium oxide. So what you have to do here, B. So you have to do the decomposition. So here, let's say there is decomposition. Yeah, this is thermal decomposition. So B is thermal decomposition. Okay, this is thermal decomposition. So when you have seawater and this calcium hydroxide, what is going to happen first? This precipitate going to form. So this is precipitation. Okay. Then when you have this precipitation, when you have this magnesium and this, so you have this precipitation. So this precipitation P is going to form. So what is P here? It should be magnesium hydroxide, right? Yeah, magnesium hydroxide. And the next step is you add HCl. So it should be like, okay, so Q, there is Q here. You don't know Q, but I think probably it should be HCl because you have the AQ. So surely this should be magnesium chloride AQ. And here it should be magnesium chloride in the liquid form because you do some removal of water here. So this E should be like evaporation. Why? Because RAQ is turned into R liquid. So this should be surely evaporation. Okay. And when you do the evaporation, then you obtain F. So yeah, so I think this probably should be this electrolysis. Okay. F is electrolysis because you have obtained magnesium solid. So F is electrolysis. Okay, everything is fine now. Yeah, so then, so when you do the electrolysis, one product is magnesium, the other one is chlorine. So chlorine, when react with water, will give Q. So Q is surely HCl, which is why we use, when you have magnesium hydroxide here, we use HCl to form the chloride. So Q is HCl, right? So this is what this recycling of a reagent. So G is recycling of a reagent. So electrolysis is done, thermal decomposition, evaporation, precipitation. Okay. So this one is dissolution. Then D is dissolution because magnesium hydroxide is converted to magnesium chloride. So this is dissolution. You see here, when you know this Dow process, then you can predict these reactions. Okay. I cannot tell when you by heart this one, you will get this one, but you need to understand what is actually happening here. That is the reality. Okay. So seawater is there, calcium carbonate or brolamide, we don't know. You do the thermal decomposition and the precipitation, you will get magnesium hydroxide, and then you add HCl and do the dissolution, you will get magnesium chloride, RAQ. Then you evaporate this to get the magnesium liquid, you electrolyze to get magnesium solid, and during the electrolysis, you will release T, which is Cl2 gas, and the Cl2 gas react with water to form HCl and O2, and this HCl is regenerated. So this is an advantageous process. Why? One of the important reagent is recycled here in this process. So this is really good. Identify the chemical compound used in B. So what is B? So this could be either calcium carbonate, limestone, or calcium carbonate or dolomite. You can write that. Okay. So you can write down either calcium carbonate or limestone. That is enough. Identify the chemical species PQRT. So I told you. So P is magnesium hydroxide, R is MgCl2 Q, then T is chlorine, Q is HCl. So these are very simple things. Give balanced chemical equations, half reaction for the processes taking places at B, C, D, and F. So this is where you need to understand. So what is B here? Calcium carbonate decomposition. So you need to write calcium carbonate decomposes into calcium oxide and carbon dioxide. C, you need to write calcium oxide with water. The same reactions gives calcium hydroxide. Then calcium hydroxide gives calcium 2 plus and OH minus as here. Then magnesium 2 plus react with this OH minus to form magnesium hydroxide. So there are 3 reactions that you can write down here. Okay. And D is magnesium hydroxide reacting with HCl to form magnesium chloride and 2H2O. And F is the electrolysis. So you can write down the 2 electrode reactions, these 2. Okay, so balance this one as well. Here there should be 2 electrons added. State the importance of the reaction occurring in G. So important is what? One of the reagents, HCl, used here is recycled. So it is cost effective. That is the advantage. Okay, cost effective. These are very straightforward things. The only thing that you need to know here is the Dow process and what is actually happening there. Right, moving on. Consider the industries given below. So you have several industries given: coal power plant, refrigeration, transport, agriculture, animal farming. Yeah. So all 5 industries given above contribute to global warming. In fact, yes, that is correct. Identify the gases, chemical species, as already said. So you need to just think about what are the species that can affect the global warming, which means what are the greenhouse gases that emitted from these industries. Typically, coal power use carbon dioxide, carbon. So carbon dioxide will be formed. Refrigerators, we know CFC can be formed, or either HCFC can be formed. Transport, again, CO2, and maybe there can be, I think, yeah, generally we take CO2. Agriculture, generally in common is CH4, but there can be nitrogenous compounds in agriculture, like N2O is greenhouse. And in animal farming also the common is CH4. State 3 adverse climatic changes that could happen. So global warming means gradual rise in the temperature. So first thing that would happen is there will be high temperature. Means what is going to happen? There will be polar glaciers, ice caps. They will dissolve. Okay, so what is the next consequence of it? So dissolution of the polar ice caps will increase in the sea level in some areas. So there will be tsunami type of things in some areas. And because of this, some forest and everything will be destroyed. So there will be deforestation that can happen. That is the third point. And the other thing that can happen is when these changes, that means deforestation happen, the rainfall patterns could change. So in some areas there will be heavy rain, and in some areas there will be no rain. So these things can happen. Okay, this is very simple. Identify the main industries given about contribute to photochemical smog. So first, photochemical smog, you remember that is mainly from the vehicle emissions along with some scattering from other particles. So transportation will mainly happen this one. Acid rain. So acid rain in general here will be from the coal power plants, because there can be these sulfur compounds that is emitted from here that gives SO2 gas, then forming sulfuric and acid rain. And eutrophication is generally from agriculture and animal farming. Okay, so don't forget. And also acid rain also can be from the transportation as well, because nitrogenous compound will form NO2 and the nitric acid. So eutrophication, agriculture, plus farming, animal farming. So those 2 can come. Due to the reduction in the rainfall in Sri Lanka, so inducing artificial rain has been tested. So you add salts and you condense water to form the artificial rain. So that is what they have done. So they have added these salts. And they are asking from the list given below, select the water quality parameters that are directly affected and unaffected. Okay. And what is affecting basically? So you have the, where is the water quality parameter given here? I think I'm missing some. Yeah. So I think I have to check what are the water quality parameters given. Okay, so basically they have given pH, conductivity, turbidity, and dissolved oxygen. So pH, conductivity, turbidity, and dissolved oxygen. So the list is given, that question part is missing. So what is affected here? So think about these salts. So NaCl, calcium chloride, NaBr, all these are neutral salts. Okay, so when you add these things, they are not going to get hydrolyzed. Okay, or they are not going to get hydration. There is no hydration between these. Only the hydration can happen. No hydrolysis is happening. Okay, don't forget, hydrolysis is not happening. Hydration is only happening. So there will be no effect to the pH. Second one, conductivity. So as I told you, as I explained you in the MCQ paper as well, when you have a lot of ions, the conductivity is going to affect. So directly affect this conductivity. So affected conductivity. Why it is affecting? There will be more ions, so there will be more conductivity. Turbidity. So think about these chloride and bromides. They will not form these precipitates in water, right? So generally they are soluble. They are really soluble. Unless they have like D block cations, they are completely soluble. So adding that into the process is not harmful. So they are not going to form precipitate. So there is no effect. And the other one is dissolution. Yeah, dissolve oxygen. So oxygen also no problem, because these anions would not react with oxygen. So basically affected is the conductivity. So why it is affected? More ions, more conductive. Unaffected pH. Why the reason? Because these are neutral salts, so they will not hydrolyze. They will only get hydrated, no pH effect. And turbidity, these are not forming precipitate, so no effect, no turbidity. And for dissolved oxygen, so they will not react with oxygen, so no problem. Okay, so you have to write all these things. Okay, the last part is based on the biodiesel production. So state the raw materials used in the manufacture of biodiesel. So you know, I think you might have known in the present cases, there are many people trying to find alternative energy resources. So one of the alternative energy resources is biodiesel, because people think in more than like 30 to 40 years, we are going to limited with our fossil fuels. And also fossil fuels is not good because of its burning and giving a lot of carbon dioxide. So basically we use for this one, plant oil is necessary because they have triglycerides. So what is the normal method to produce biodiesel? You get the plant oil, you add methanol, and you break down the triglyceride to form the ester. That is how biodiesel is formed. So you need plant oil, so you need methanol as well. Okay, so you need methanol. That is the other thing that you need to know here. So these are the two things. So basically when you have the plant oil, so you have this structure for the triglyceride, CH2O, CO, R. This could be R1, R2, CO. This could be R3 here. Then what you can do is you add methanol and heat the solution. You can add the catalyst as NaOH or KOH as our catalyst to speed up the reaction. So basically this bond will form here and it will form the glycerol molecule. Okay. Glycerol molecule is CH2OH, CHOH, CH2OH. Okay. This is glycerol. Plus there will be this RCOOH. RCOOH. This is R, this is 3 times R. If this is R1, R2, R3, R1COH, R2COH, R3COH. So that is good. This is what normally called the initial process that is going to form. And then since you are adding this methanol, so this will react with this one and form the ester product. Okay. Name the main chemical compound present in each raw material where applicable. So basically methanol is methanol. Plant oil, the main chemical compound is this one. This is called triglyceride. Okay, so that is called triglyceride. So you can write down here triglyceride. Triglyceride. State the name of the chemical compound used as the catalyst. So basically the catalyst is NaOH, right? Sodium hydroxide can be used, or either potassium hydroxide also used. Give the balanced chemical equation to show the synthesis of biodiesel using the chemical compound. So this is the reaction. So if I want to write down this in one particular reaction, I will write down this one. So since 3 molecules are formed, 3 methanols are needed. So I will write down directly the ester plus the glycerol molecule. I will not write down this one. Okay. My reaction will be triglyceride plus 3 methanol, arrow. So I will add a NaOH, glycerol molecule plus 3 esters. Identify the side reaction that would take place along with this product if the catalyst is used in excess. So basically what is going to happen? So again, an ester is formed, but if you use the catalyst excess, what is going to happen? This ester will eventually cause the hydrolysis of this ester and form the fatty acid. Okay, this is basically called the soap. This is how we prepare soap. You have the ester and you add the NaOH and get the soap. Or this is also typically called the saponification reaction. First step of the salt production, saponification. Okay, so that is the disadvantage here if you use high amount of NaOH, but normally we don't need, right? Because catalyst, the advantage of catalyst is one of the advantage, right? To use very low amount.